Hi, I'm Rachel, a program manager with the Azure PlayFab Multiplayer Servers team.
Hi everyone, I'm Emma, a software engineer on the multiplayer server team. I'm really happy to be here.
This session will be an introductory course into what Azure PlayFab Multiplayer Servers is, otherwise known as MPS. This is for those who want a session-based multiplayer games easily scaled for you on the cloud. We will cover what MPS is and some known key concepts we believe you should know before you start. Then we'll get into how to create a build and using local multiplayer agent. From here on out, we'll refer to multiplayer servers as MPS, and local multiplayer agent will be referred to as LMA. So we're a component of Azure PlayFab, which provides a larger set of services like party and matchmaking and other wonderful services that power some of today's biggest games. So first, I wanted to dig into what MPS is. It's built on Azure's compute services, and MPS helps deliver high performance, high reliability, and low-cost game servers. MPS helps you operate a dynamically scaling pool of custom game servers in the cloud for session-based multiplayer games. In the middle, as you can see, there are some great titles that utilize MPS today for their server needs. The massive scale of Azure's public cloud enables dynamic scale, global distribution for lower latencies, and a broad range of compute options that are optimized for gaming. MPS really handles all of the heavy lifting for you of globally distributing and scaling your games out in response to your player demands so that you can focus on what you do best, creating your games. Emma, can we now go over some things specifically that MPS can help with?
Yes, MPS has lots of features that simplify your game server hosting. With MPS, you can easily deploy your game servers on Azure Data Center. We also offer advanced tools for debugging and monitoring your game servers such as VM metrics, local multiplayer agent, crash dumps, profiler, and generic logs. Tune into our second course to learn more about these and other great capabilities we offer. This is an introductory course, so we will mainly focus on how to deploy game server with MPS game samples.
So now that we've established what MPS is and we've seen some titles that we've empowered, let's see how this works. Emma, what are some key concepts that we should go over, though, before we dig into how to deploy and create these game servers?
So as you can see in the diagram, PlayFab is a central hub that handles requests and responses related to the game servers. MPS' main role here is to do game server hosting setup for you. Create VMs and make your game servers running so players can quickly connect to the game servers. Keep in mind that game servers need to be integrated with GSK.
Real quick before we keep going, what is the Gstk? Can you explain a little bit about that?
Of course. The GSK or Game Server SDK is a communication middle layer between MPS and game servers. GSK is an open source available on GitHub provided in multiple languages. To learn how to integrate GSK with your game servers, check out PlayFab Multiplayer website or samples on GitHub.
Nice. So now that we know what the Gstk is and how, once we integrate it, what do we do next?
So next would be to deploy your game servers. To deploy your game servers, we need to provide some information to MPS. Let's say I want to deploy at least 5 game servers running on Windows VM in the West US. You can do this by creating a build.
Awesome. So now that we know what a build is, can we talk more about what information we need in order to create a build?
First, we need a build name. Then we choose VM information such as VM size and number of server per machine. For operating system, MPS supports both Windows and Linux VM. And then you need to choose game server type, either process or container. If you choose game server type as process, then your game servers are deployed and scaled as process. If it's a container, that means your game server is built into a container image and will be deployed as container. You will also need to add in your start command. Once your VMs are up, the start command will run your game servers.
It's a lot of great stuff. But what else should our users know before going out and creating their own build?
So one thing to keep in mind is port mapping. You need to put port information here to tell MPS, hey MPS, my game server needs to open up some ports that client can connect to. I'll give you port information.
Wow, that's really cool. So can we talk more about the differences between our process and container modes, also between the differences of Windows and Linux?
Of course, for process mode, you just need to upload your game server. Port number will be mapped internally, so you don't need to specify port number when you create a build. When you deploy game servers as container on Windows, you just need to upload asset because MPS will build container for you. Make sure that game start command should be a full path, including a specific mount to path asset drive under C. For Linux container, you need to build Linux container and upload it to Azure container registry. You can get credentials for ACR on the build page and choose container from ACR. More details on difference between container and process game servers, please refer to our advanced MPS demo.
So now that we've finished adding the build, are we done?
Yes, but before we jump into the demo, I want to talk about LMA a little bit. You might want to test your game server as it's running on MPS. Without any cloud connection, LMA can run your game servers on your local machine. It will run a diagnosis on your game server and verify if your game server is integrated with GSK. You can see LMA has a testing ground for your game servers before you roll out your game servers globally.
Wow, that's really cool. I'm really glad that we have that tool for debugging and other things. But what if our games aren't ready quite yet, but we still want to try out MPS to kind of see how that is?
Good news is MPS has multiple samples available on GitHub. For this demo, we will use wrapper sample. Wrapper is already integrated with GSK and includes a fake game. If you like to test your own game servers, you can easily replace a game server with your own game server.
Awesome. So now that we know about the basics, can we walk through what this actually looks like when we go through the full process?
Sure, let's jump into the demo. You can see this page once you log in PlayFab account and click Multiplayer tab here. I'm using our team account. As you can see, a lot of builds created here. We want to create a build, so let's click the New Build button. It will take you to this page. So let's call this build name GDC 2022 with MPS. For virtual machine, I will choose DASV for 2 cores and 4 game servers. To distribute, this number will decide how you dedicate CPU cores to your game servers. If you choose 2 cores per VM and then 4 servers, that means each server will occupy 0.5 core. The virtual machine size and servers per machine depends on how you scale your game servers and how many computing resources that a build requires. And I will choose process and Windows virtual machine because I'm going to deploy wrapper game servers as process without container. And here are some great features to call out. If you enable virtual machine metrics preview, you can access system level overview such as CPU usage, memory usage, and network. Also, you can try out latest version of the Windows by enabling use Windows Core Preview. And also, we support a crash dump collection, and this feature is only available for Windows container. Today, I will leave these great features, but you can also check out MPS documentation to learn more about it. And next, game asset. Upload your game asset as an archive format to the asset section. If you upload your asset before, you could just click Use Existing Asset and then click the game asset you want to use. For this demo, we have wrapper sample and the name is GDC Wrapper Demo 2022. And I will add to this build, and then I will type start command that will run wrapper sample. Here, the start command is wrapper.exe -g fake game.exe arg1 arg2. If you are using your own game server, you can easily just replace this fake game to your own game server name. Now we choose regions, where your game servers will be deployed. In terms of standing by, it simply shows how many servers will be in standing by states. The benefit of it is players can quickly access the game. This simplify increase the game server experience. Make sure standing by servers should be less than max game servers. For example, if you have 2 game servers, MPS will maintain at least 2 standing by servers, but will not exceed the maximum number of servers, which is 4 here for this demo in this region. You don't need to worry about getting charged as you set the limit here. Now we need to specify the port information. Make sure wrapper is already integrated with Gstk that includes the port information as game_port. When fake game will open the port for connection, it will use that port name and the protocol will be TCP. Now we put all required fields here. So I will add a build by click this button. But we create a build, and this build will take a few minutes to deploy. So we prepared one before for this demo. So here, as you can see, we have the same configuration, but it seems build failed. Rachel, can you see anything wrong in this build?
It looks like it was all copied over correctly, but I don't see anything that's popping out. Why don't we test the wrapper sample with using LMA?
That's a great idea. So I already have LMA and wrapper on my local machine. So in this extracted folder, you will find a multiplayer setting.json file, which LMA will need to run your game servers. The multiplayer setting.json is a mock of your build configuration. I already opened it in a text editor using Visual Studio Code, and you can see this has the same build configuration as we just put when we create a build earlier. For example, we set run container false because we want to test our game server as process, and this is the output folder, that path where your output files will be generated. And this is all the default settings that you can ignore right now. But here is the local file path where your game asset located. Here we have GDC wrapper demo 2022 under GDC demo folder, and you can find there is a GDC wrapper demo zip file here. And then put process start command that will start your game servers. Here we put wrapper.exe, which is same start command we just put when we create a build. And here port mapping information. So in a PowerShell window as administrator, cd into the folder where the LMA was extracted and run local multiplayer agent. So now agent is verifying information on your game servers. So our goal here is see our game servers became active. But since local LMA stops and is telling us there is some wrong configuration on our port mapping. Rachel, do you see anything in this port mapping section? Because I feel like I put the right information here.
Let's take a look. The only thing I can notice is that we missed the underscore between game and port.
Okay, so I didn't put underscore between game and port. So what happened here, wrapper is trying to get port information using port name as game_port, but we missed underscore in the build configuration, so wrapper couldn't find it. And this is common mistake we all make, right? So I updated the port name, and then we will run local multiplayer agent again. So LMA is verifying information here. And you can see our game state is standing by. Now we're waiting for active. So game state is active. That means your game server is healthy, integrate with Gstk, so you're good to deploy your game servers. So before we go back to our build page, Rachel, do you have any questions?
Yeah, so that's a lot of typing of the JSON. Do we have something that can help us with the creation of that?
Yes, so LMA also has a web page that will generate JSON file for multiplayer setting.json based on your input. So please check out our MPS Git website to learn more about what is JSON generator. Let's go back to the build page and create a build with the correct port name. So we go back to the build creation page and already set the values. And one thing to keep in mind, we put the game port with the underscore and then put TCP and create a build. So this is gonna take a little bit while. This is gonna few minutes to deploy your game servers. So we also prepare one before, and you can see our build deployed and everything seems correct. So we put the right port name and then TCP, and we use our game asset. So we just deploy our game servers.
That's awesome. So I know earlier, Emma, you talked about logs, crash dumps, and things like that. Where can we go to find that kind of information?
Yeah, so actually we really provide a good feature to debug your game servers when your game server failed or what happened, to see what happens. So for example, here your build failed and you go to servers tab and you can see too many game servers restarted. So you want to see the logs, then you can just click the archive servers. And these archive servers will have game logs for each session. And you can download the log and also open it and see what errors or what logs they have. So you can see they also have some logs. For example, they cannot find game port in Gstk config settings. So this is very useful when you want to see any logs quickly and debug some issue.
Thanks, Emma, for that great walkthrough. So now that you've seen what we can do, if you'd like to check out our other talks, we have one around Kubernetes, which we call Thundernetes, and also check out our advanced talk that we have as well, which is focused on scaling and debugging. You can also join our Discord to chat and ask questions, connect with the community, talk to other people about how they've used MPS as well. If you want to try it out, we also have a free tier. You can just go to playfab.com and you can sign up and start using it today. We also have links for our documentation if you'd like to learn more about that. And also check out our GitHub for other samples, including the one that Emma was talking about, our wrapper sample, along with the local multiplayer agent as well, and the JSON generator are all located on our GitHub pages. Thanks for joining us today.
Thank you.